The learning target for today is to solve equations using nth roots. And to solve an equation that's in the form something to the nth power equals a value, okay? In particular, u to the n equals d. U is just an algebraic expression such as x plus 3 or x. What you want to do is you want to take the nth root of each side, which will undo the exponent. Basically what you want to do is you need to get the exponential part of the equation by itself so that you can undo that exponent with an nth root. Now, as you're solving these, it is really important that you remember about how the index and the radicand determine the number and type of real nth roots you're going to have. You may want to go back and review the lesson where we introduced the real nth roots of a, just to practice and to remember what the index and the radicand tell you about the number and the type of roots. There is a little reminder here about when m is even and you have a positive radicand. Remember, you will need to include both the positive and negative roots when you're solving. Again, the way I kind of remember when I need to include the positive or negative and when I don't is when I am just simplifying a radical that's been given to me, I can assume that I only need the root that's implied by the original problem. However, when we're solving like a problem like this, there is no radical. I am going to have to add the radical to the problem. That is when I will need to include all possible roots because I'm not really sure which one the problem is looking for. But again, our main goal is to get the exponential part of the equation by itself so that we can use an nth root to undo that exponent. If we look at example A, we have 4x to the fifth equals 128. The 4 is not being raised to that fifth power, so I need to get rid of or undo the 4 first. Since it's 4 times that, I'm going to undo that using division, and that will get me to x to the fifth equals 32. Now, to undo the fifth power, I am going to introduce to the problem the fifth root. Notice I have an odd index and a positive radicand. I will have one positive real nth root. The fifth root and the fifth power undo each other, so I will just be left with x, and the fifth root of 32 is 2, and there is your solution. When you have something like example B, where you have an expression raised to a power, this is absolutely no different. Just make sure that the part with the exponent is by itself, which it is, and then use the nth root to undo your nth power. Since I have this expression raised to the fourth power, I am going to undo that by using the fourth root. The fourth root and the fourth power will undo each other, and you'll be left with x minus 3. Notice here I've got an even index with a positive radicand. I will have 2 real roots. So the answer will be positive or negative, and I worked out this fourth root of 21 ahead of time, approximately 2.14. Now, my ultimate goal is to solve for x, and notice the x is not by itself yet, so I would need to add 3 to both sides, and I am now at x equals 3 plus or minus 2.14. This just means that there are 2 possible solutions. One solution can be found by doing 3 plus 2.14. The other solution can be found by doing 3 minus 2.14. The first solution is 5.14. The second possible solution is 0.86. Let's review one with a fraction. Okay. Example C is very similar to example A. I need to undo the 1/2 first. Remember, the best way to undo a fraction is to multiply by the reciprocal. So I'm going to multiply both sides of this equation by 2 over 1. That will undo the fraction. I will just be left with x to the fifth, and 512 times 2 gives you 1024. Again, to undo the fifth power, I'm going to use the fifth root, and that will give me x equals 4. Example D is similar to example B. I have an expression raised to the third power, so I'm going to undo that with the cube root. That will leave me with x minus 2, and the cube root of negative 14 is approximately negative 2.41. And then to solve for x, I would add 2 to both sides, and I have a final answer of x equals negative 0.41.